What role does satellite imagery play in studying sea ice conditions in polar regions? If you are curious about how scientists keep track of the ever-changing sea ice in the polar regions, you are in the right place. Let us explore how satellite imagery plays a vital role in this process. Satellite imagery is the backbone of sea ice monitoring. It allows scientists to track changes in sea ice cover over vast areas, which would be impossible to do manually. One of the key tools used is passive microwave satellite instruments. These instruments can collect data through clouds and in the dark, which is essential for monitoring sea ice year-round, especially in the Arctic where sunlight is limited during winter. These satellites, such as those with the Scanning Multichannel Microwave Radiometer, SMMR, Special Sensor Microwave Imager, SSM/I, and Special Sensor Microwave Imager, and sounded SMIs, detect microwave energy emitted from the Earth's surface. This energy is different for sea ice and open water, allowing scientists to map sea ice concentrations accurately. They can show grids of sea ice concentrations and summarize annual cycles of ice extent, which is the area with at least 15% ice cover. In addition to microwave data, satellites also use infrared sensors to measure the temperature of the sea ice. Since sea ice is much colder than the surrounding ocean, infrared sensors can distinguish between the two. However, there are some limitations. For example, clouds can interfere with infrared radiation, and during the summer, melting sea ice can be hard to distinguish from the ocean because both are near the freezing point. Satellites like CryoSat-2 and ICESat-2 are also crucial for measuring sea ice thickness. CryoSat-2 uses a synthetic aperture interferometric radar altimeter to convert data into maps of sea ice thickness, which helps in tracking changes over time and monitoring winter ice growth. ICESat-2 provides Arctic-wide thickness estimates on a monthly basis, helping scientists understand the decline in multi-year sea ice thickness. The data collected from these satellites is combined with other observations, such as those from aircraft like NASA's Operation IceBridge, to get a more complete picture of sea ice conditions. This combination helps in understanding the extent, frequency, and depth of melt ponds on sea ice, which are critical for predicting the minimum ice extent in September. Monthly sea ice maps, such as those produced by Copernicus Climate Change, use data from these satellites to show the fractional ice cover over a regular grid. These maps help in tracking changes in sea ice area and extent over time, providing valuable insights into climate trends. In summary, satellite imagery is essential for studying sea ice conditions. It provides continuous, detailed, and accurate data on sea ice extent, concentration, and thickness, which are vital for understanding climate changes and their impacts on polar regions. Whether it is through microwave, infrared, or radar data, satellites are the primary tools scientists rely on to monitor and predict changes in sea ice.